This is the final tutorial in this series. I can't believe how far we've come since the beginning of the semester, and we're going to end our journey on for loops. So last tutorial, we looked at repeating things in R without for loops, and this week we'll learn about for loops. They're a little more complicated to think about, but now that you have some background in building functions and the apply family, hopefully this will make a little bit more sense. Let's look at the basic structure of a for loop. The fundamental structure for repetition in programming. This is across many different languages. And we use for loops when we want to do the same action to each item in a list of things. So the basic structure of a for loop follows, we call the for item in list of items. Do this thing, do something on this item. And you also might want to return something as well. So that's the basic structure, and you actually need return or print to display values inside of a loop or function. Let's see a basic for loop by first creating a vector called volumes with 3 values. And let's create our for loop for some index. We could call this thing, this item, anything. In this example, I'll call it volume. For each thing in volumes, so this is the object that we want to work with, do this thing inside the curly brackets. Print this equation, this value 2.65, volume to the 0.9. Notice how I'm using the item, right? So take this item and do this thing. So in each iteration of our for loop, it'll take this item, calculate this equation, and print the value. Then in the next loop, it'll take the second element, calculate this thing, and print it. Then I'll take the third element in the last cycle of this for loop and print the thing. So this for loop is the equivalent of assigning the first element to volume, and then printing this value, and then assigning the second element to volume and printing that value, and then assigning the third element, that should be our volumes vector that we created, assigning the third element in this vector to volume, and then calculate printing this value. So let's go ahead and run through these so we can see how the different values that are calculated. So internally, this is what our basic for loop is doing. It's assigning each element to the item and then using that to calculate what's inside of the curly brackets. You can also have multiple rows in a loop body. So let's take this item in volumes and do this thing inside the curly brackets. Create an object called mass as this equation, similar to what we did above, 0.9. And then create another object called mass pounds and calculate it as this equation, and then print the value of mass pounds. So our volumes is still the the numerical vector, so it'll loop through each of those values, calculate mass pounds, and print the value of mass pounds. In this example, we're using a random name that we assigned to our item. And notice how we call that item inside the for loop body. In this example, let's talk about how you would loop using an index with an index and store results. Looping over integers uses those integers to access the vector at the associated positions. So instead of using volume, the word volume, we could use an index called I. So let's use an index for I in 1 to length volumes. And remember that we're telling R basically that there'll be 3 loops to do this 3 times. For I equals 1, for I equals 2, for I equals 3. So for I in 1, 2, 3, do this thing inside the curly brackets. We're going to calculate mass, an object called mass, using the same equation we've been using. But instead of calling volumes now, instead of calling our item, which was volume in the previous example, right? We called volume the item. Now we want to call the vector volumes. And instead of assigning it a volume, we can use the index notation. So now we're being very explicit about the element that we want R to pull from. So when I is equal to 1, R calculates mass using the first element of volumes. When I is equal to 2, it pulls out the second element. And then when in that third loop, I is set to 3, so it's pulling out the third element inside this object. In this case, it's a vector. So let's go ahead and run this for loop using this indexing, and I'll change the screens a little bit so we can see how through each loop the value was calculated using the element stored inside our volumes vector. So it uses this index to get the value at a particular position. And you can also use the index for multiple vectors. Looping with an index allows us to store the results that are calculated in this loop. So the first thing we need to do, in order to store the results, we need to create an empty object. Let's create an empty object using this vector function to tell R that we want to create this vector object, and we want the mode, we want that vector to be numeric, and we want the length to be the same length as our volumes vector. We could have replaced this with the number 3 because we know that our volumes is length 3. But in order to have our code be as general as possible, we can specify that our length will match our volumes vector. So let's go ahead and run this. So we have this, let me print it here too so we can see it easier. So we have this empty object, right? It has is automatically filled with zeros, and R understands that this is a vector, a numeric vector of length 3. Now we can add each result in our for loop to the different positions in our masses vector. For each trip through the loop, we're going to tell R to put the output into the empty vector at the ith position. So the first position for the first loop, the second position for the second loop, and the third position for the third loop. And this is possible using the indexing I notation. So we've got our empty vector. Now we can store those results inside the vector by creating this for loop. So for I in 1 to length volumes. So for each iteration, do this thing inside the curly brackets, create an object called mass using our familiar equation, pull out the volume, the value for volumes at the ith position, so the first, second, or third position in this example, and then store that value inside the ith position in this empty vector created. And then we want to print out our filled in masses vector. So let's run this and look at the values, and then go through each loop what it's doing. Okay, so for the first iteration, R is going to calculate mass using the first element in volumes and store it as mass, right? And then it's going to store the value of mass at the first position inside our masses vector. And then it completes the for loop. And when it's done, and it knows it's done because we've told it that there are 3 loops, right? There's 3 iterations. So when it hits that third and final iteration, the for loop stops and it prints out the values of masses. The benefit of looping with an index is that it allows you to access values from multiple vectors. So in this example, we were specifying the volumes vector, but let's see an example where we're looping using values from multiple vectors. So let's create 2 vectors, b0, and let's give it some values, 3.29, and let's create a second vector, b1, 0.9, 1.1, and 1.2. They each have 3 values. Now let's create our empty vector again. So I'm going to call it vector, and you can create an empty data frame or an empty list depending on the type of output you're interested in. Length volumes. And this is exactly what we did before in the above example. And now I'm going to say, okay, in my for loop, for each iteration, and I'm going to use a function called sequence along volumes, which is exactly the same as 1 to length volumes. So it creates a sequence of 1 to whatever the length of the object you give it here. And so it's the exact same if we were to write 1 to length volumes. So 1 to length volumes is creating a sequence of values of 1 to 3. And that's what sequence along is doing. And it's a little more concise. So for each iteration in 1 to 3, do this thing, create an object called mass, and inside of it, inside mass, calculate this value using the if element in B0 and the if element of volumes raised to the if element of B1. So it's going to pull out the if element inside each of these vectors. So in the first iteration of the loop, it'll pull out the first element, so the value in the first position of each of these vectors. And then we want to create our masses and store that value inside the if position of our masses vector. So in the second iteration, it'll take the second value from B0, the second value from volumes, and the second value from B1, store that as mass, and then store the value of mass inside the second position of masses. And for repetition, sometimes that's good for learning, in the third and final iteration, it'll take the value in the third position of B0, the third element in volumes, and the third element B1. Store that value as mass, and then takes the value of mass and stores it in the third position of our masses vector. Notice how in each iteration, our mass object is being overwritten. Whereas in our masses vector, we're telling it to store the value in a certain position. In for loops, you often overwrite intermediate objects like this, and then store the object in a certain position. And I haven't run it, so let's go ahead and run that entire segment where I'm creating the vectors, the empty vector to store the results in, and the for loop itself. And notice how it didn't print anything because I didn't print out the value of masses. So I can go ahead and do that, print out masses, and we can see that there are 3 values for each of the iterations or loops. So there are 3 of loops. So we've seen in an example of looping over using the indexing notation. Let's see an example of looping over files. Sometimes you want to repeat the same action on many similar files. And in this example, we'll get the names of satellite color location files. So these are satellite colors that have been placed around small mammals, I'm assuming. So I am going to copy and paste the download.file function from our canvas. So we're going to download file. This is the URL. And then this is the destination. And I'll run this and okay, I had to change the URL, but now we should be able to unzip using the built-in unzip function. And now let's create an object called data files and use the list.files function to list all the files that have this pattern of locations dash dot, and we'll use the asterisk symbol to designate that we don't care what's in between these two dots, that it could be anything. And then we want to return full name. So we want to set full that names equals true. So now we've created this data files object with all the file names. And it's listing all the file names. And notice how it recognizes that after the dash, and it doesn't matter what's in between the dash and the .txt. Now, based on these satellite color locations, we want to calculate the number of observations in each file. So the first thing we need to do is create an empty object. In this case, we want an integer vector of length equals the length of our data files. And that should be an underscore, data underscore files. Now we can begin our for loop. So for each iteration in 1 to length data files, remember you can also use sequence along to create the same sequence. Do this thing in the curly brackets, create an object called data, read.csv, the using the name that is stored in the if position of our data underscore files object. Then create an object called count, and in that object store the value that is calculated from this n row, the number of rows in our data, and then store the results in the if position from our count object. And notice again, every iteration will be rewriting data and count, but storing the final count inside of our results vector. Let's go ahead and run the for loop. And now look at our results vector. So we have different values calculated for each of the different files. In this example, we stored the output in a vector, but sometimes, a lot of times, you'll want to store the output in a data frame instead of a vector, and associate the file name with the count. So you know, in addition to the number 4, 8, 10, these values, you also want to know kind of which file it came from. So let's see an example of that by creating a data frame now. So let's create an empty data frame and overwrite our results object. So we'll create a data frame, and we want a column called file name, which will be a character, and it'll be the length of our data files object. Sometimes that pop-up box really gets in the way. And we want a column called count, which will be an integer, the same length of data files. And we want strings as factors equals false. And I've got some bad accounting here. So length, that closes, count equals integer, and this closes the data frame. So we have a column named file name, a column named count, and we don't want our strings to be converted to vectors. Invalid length argument. And that's because here length is a function and not an equal sign there. All right, so we have this empty data frame, right? It's got no values. Now we can begin our for loop. For each iteration in 1, 2 length data files, again, you could use sequence along if you wanted to. Do this thing in curly brackets. Create an object called data where we read in the CSV for each using the name provided in our data files position. Then create an object called count where we calculate the number of rows for this data frame that we created and stored inside of data. And now, because our results object is a data frame, instead of using the index like we would if we were using a vector, now we can use the $sign notation to designate the particular column, then the position. Right, so we're telling our store the results, store the name of data files in this if position. Remember, these are the names of our files. Inside our column file name for the ith row. Let's repeat this for our results count for the ith row in this particular column, and we'll store the results of count. And then we'll print out the results object. So let's take a quick look at our data files object, right? So we can see the different positions or elements, 1 through 5. So there'll be 5 iterations of this loop, of this for loop. So the first iteration, it will, right, we're creating a data frame using the read.csv function, similar to how we've been doing these past few weeks. And it uses this name, right, inside here for the first element. And then it'll use this name, this value for the second iteration, this value for the third iteration, this value for the fourth, and this value for the fifth. And then it'll proceed, right? For each iteration, it'll pull in this value, right? So in the first iteration, it'll pull in this value. Then it'll calculate the number of rows for this data frame. Then it'll store the name of the data file in the first row of our file name column. Then it'll store the count in the first row of our count column. So let's go ahead and run this and see the results. So now we've got the file name printed in this column and our count column with each of the values that were calculated using nrow. Sometimes for loops get very large, and we can use the apply family of functions. Let's see an example of using this kind of repetitive process using apply. Let's create a function called getCounts, and your inputs will be the data file name, and this inside this function we'll create a file object, very similar to using the for loop, and a count object where we're calculating the number of rows in this file and return the value of count. So apply. Let's create an object called results, and we're going to use lapply, but we want a data frame and not a list. So we're going to use this onList function on our, we're going to call this our color data files. And this should be our data underscore files, get counts. And now we can see our results did not work the way that I thought it would. So I'm going to go back and check to see what I did wrong. And I'm going to first review the function itself. So the function expects some input value that represents the file name. Then it uses read.csv to import that file name into an object called file. And then it counts the number of rows of the data frame, and it returns the count. Okay, so we do expect a vector of counts. And when I run this and return results, we have the vector of counts. So we're seeing multiple ways of doing the same thing, of this repetitive process on different elements of a file or a data frame or vector. So how do you choose when there are many ways to do the same thing? Well, sometimes speed is a factor to take into consideration. Sometimes speed matters in a few cases, especially when you're working with really large data sets where it's really hard to identify what the bottlenecks are. In a lot of cases, an apply function will be faster than a for loop, especially if there are a lot of different steps inside of the for loop body. Sometimes it's for readability. If you're working with an apply family of function and there's lots of different arguments, sometimes it's easier to just to go with a for loop. And sometimes it's personal preference. You might find that for loops are a bit more intuitive than functions combined with the apply family. And so you stick with for loops. And it's a personal preference. There's no right way to do anything. So this wraps up our R tutorials. You've come a really long way, and I've been so impressed by you all. I've learned a lot from you in terms of how to talk about R code in a way that's easy to understand. And I hope that you've taken something that you can use in your own work. So nice job.